In this demonstration, we're going to show how you can animate the power flow through a transmission. Our model is of a dual clutch transmission. The flow of power through the transmission is controlled by the states of two input clutches operating in parallel and dog clutches, which pre-select the next gear to which the transmission will shift. We'd like to animate the flow of power through this dual clutch transmission. We're going to do that by using Simulink 3D animation to animate the results of a sim driveline simulation. Our sim driveline model contains gears, dog clutches, and the input clutches that control the shifting of gears in the transmission. We're going to send the simulation data to Simulink 3D animation to produce this 3D animation, where you can see that the flow of power is highlighted in orange as the transmission shifts gears. I'll now switch over to the model so that you can see how this is done. Here is our model of a dual clutch transmission developed in Sim Driveline. You can see we have modeled the two input clutches, which are connected in parallel. They connect to two shafts which feed to the rest of the transmission. Here you can see the even gears connected to the even shaft, the odd gears and reverse connected to the odd input shaft, and then the dog clutches which pre-select the next gear to which the transmission will shift. First, I'll show you the test rig where we developed the animation, and then I'll show you how that integrates into the overall simulation. Here is the model that we used to test the animation. This simulation is controlled using this GUI developed in MATLAB. I'll start the simulation and then use these buttons to shift between the gears. As I shift to a half gear, a dog clutch will engage the next gear to which the transmission will shift. As I shift to a full gear, you can see that the input clutches will change state, again controlling the next gear to which the transmission shifts. The flow of power is highlighted in orange, so you can see that the flow of power goes through the clutch for the odd gears plus reverse to this shaft, which is connected to the odd gears and the reverse gear, through gear 1 to the dog clutch, which is connected to the output shaft, and then this connects to the rest of the drivetrain to the wheels. As we move up the gears, again on the half gear, the dog clutch engages the next gear to which the transmission will shift, and then on the full gear, the input clutches change state. We can also go down to reverse gear. So if we go down to gear -1, you can see that the reverse gear is selected. And if we switch to the perspective view, you can see that there's an additional shaft, and this additional shaft is ordered to reverse the direction of rotation for reverse. So now that we've seen how the test rig has been used to test the animation, we'll now show how it integrates into the overall model. In the overall model, we sense key quantities, such as the displacement of the dog clutches and the angle of rotation for the different shafts, the input shaft, the output shaft, and so on. And those Simulink signals are fed to the connection to Simulink 3D animation. If we double-click this subsystem, this will open the 3D animation and we can run the simulation. So now the entire sim driveline model, which models the dual clutch transmission plus the control system and the vehicle dynamics, is running, and the results of that simulation are being used to drive this animation in real time. So this is a live animation. You can see that just as in the test rig, the gears are switching as we explained. Again, the dog clutch pre-selects the next gear to which the transmission will shift, and then the clutches change state in order to actually change gear. And you can see that the rotation of the shafts is controlled by the speed of rotation from the simulation. We've slowed this down a bit so that you can actually see what's going on. In this demonstration, you've been able to see how we can use Sim Driveline and Simulink 3D animation in order to demonstrate the flow of power through a dual clutch transmission.